All right, I guess we can start. Once again, thank you all for joining us and attending today's webinar entitled Plant Interconnection for Maximizing Efficiency, the Importance of the Interconnection in the Green Energy Infrastructure. We do understand the importance of the interconnection, and that's why we wanted to make this webinar. So before we start, I would like to introduce you to the speakers. Myself, my name is Soukayna. I'm a product manager of the interconnection products and pvDesign at Reddit Power. And today I have the pleasure to share this webinar with Tom Dunbar, who is an electrical engineer at MPR Associates. He's been conducting and managing technical projects in the industry and different facilities, including renewable energy facilities and transmission substation facilities. So basically, he's been at the core of the interconnection process. He understands all of it and understands very well, and that's why he's going to be the expert today to walk us through all the technical information. So thank you, Tom, again for joining me today in this webinar. Okay, before I leave the floor to Tom, I'm going to just tell you a little bit more about the agenda of today. So we're going to jump in first directly to the subject, talking about the interconnection application process, its importance, the background or the reason behind this process, the timeline and duration of this process, and all the details that comes with this process. Then we're going to discuss and have a conversation regarding the automation technologies and how they show up in the picture to help make this process more smooth for the applicants and make it more time efficient. And then we're going to talk about maximizing efficiency with pvDesign, which is for those of you who do not know the pvDesign and what it is the software developed by Reddit Power. And it automates the design of utility scale solar plants. And the whole presentation will be around 45 minutes, but we will dedicate 20 minutes for Q&A session. So please feel free to start dropping your questions at the questions box in the panel throughout the whole presentation. And finally, feel free to send us any question, doubt, or feedback that you have, and contact us with the feedback that you have, since we value a lot our users or potential users to develop the software pvDesign. So with that, I will leave the floor to Tom to start explaining to us the interconnection application.
All right, thank you. So just at a high level, interconnection is the process by which a new electrical generation facility is connected to the grid. And anytime you're connecting new generation, you need to make sure that it's connected safely, it doesn't impact the reliability of the grid, and you don't exceed any of the grid capabilities, such as transmission line amperages or short circuit current contributions. So the utilities want to make sure that any new generation that's connected maintains the grid reliability, and so they've set up this interconnection process to facilitate working through all those issues. Right now in the US, the US utilities are facing a wave of renewables. There's a historic backlog for how many interconnection applications are being processed right now. Just to kind of put it in perspective, give you some sense of scale. Right now in the interconnection queue across the United States, there's so much renewable energy of new generation that if all of the applications were granted and were built, the US would be 80% carbon-free electricity generation by 2030. So that's a huge shift for the US. Right now, the US has about 20%, very roughly, of renewable penetration. So the US would be looking at tripling its renewable or its carbon-free electric generation in the next 7 years. So that would be a huge shift. However, the caveat to that is that only 25% of interconnection applications are actually built. So while there's a huge backlog, the utilities understand that very few of those applications will actually see the light of day. There's several reasons for this. One of them is in the United States, developers that are creating the new generation, they are responsible for the cost of upgrades to the grid for this new generation. So if you're building a new solar plant and that's going to cause the transmission lines to be over capacity, then the developer, as part of building that new solar plant, has to build new transmission lines. That's very costly. Many developers, when they see the cost of that upgrades to the grid, they back out of the project and withdraw their application. So, so those are sort of the background of what's going on in the United States in terms of interconnection applications. So the utilities facing this historic backlog and also seeing the utilities doing all this work to study all these new interconnections and then nothing ever comes of it, have tried to increase the documentation required upfront provided by the developers in order to reduce non-serious applications, or what they call cost discovery applications, where a utility or where a developer is submitting an interconnection, maybe not really having all their designs completed, all their financing lined up, but just to sort of see, hey, what's it going to cost if we did this? So that's one of the factors that is driving a trend in increasing documentation. Additionally, NERC, the North American Electric Reliability Corporation, is also promulgating new rules that are also driving increase in documentation, especially in simulation and modeling. So you have several trends that are driving an increase in documentation when a developer submits a new interconnection application. So some of this documentation you get from the inverter manufacturer, such as harmonic distortion, short circuit contribution. Others of it, such as the modeling and simulation, need to be created. Those are things like a PSSE model or a three-phase EMT model, usually done in PSCAD or EMT-PRV, among other softwares. But then there's a whole host of other documentation that's required, and this is really where pvDesign and rated power come into play. Documentation such as the single line diagram, the tie line impedance, transformer data such as the main transformer and the inverter step-up transformers, and then the collector system equivalent impedance. Now I want to kind of focus on the collector system equivalent impedance data. That's things like the positive and zero sequence resistance, reactance, and subsistence. Now, those pieces of information are pretty hard to come by, and you have to do a whole bunch of calculations in order to figure those out. To sort of streamline this and make it more uniform across the United States, the Western Electricity Coordinating Council, WEC, provided some guidelines several years back, and those guidelines have been really adopted by most of the utilities across the United States. So even though the United States has a very diverse, shall I say, electric grid and utility requirements and so forth, nonetheless, there is some commonality across that. And creating and determining this collector system equivalent impedance really kind of became a pain point as MPR was trying to submit these interconnection applications. We had to use spreadsheets and do a lot of estimation and calculations and so forth. And so I reached out to Rated Power and said, hey, in your design, you have all the cable lengths, you have all the cable sizes, etc. Can you implement the WEC guidelines and automatically calculate the collector system equivalent impedance? And working back and forth, I'm happy to say that Rated Power created those values. And so now, as part of the system design, we get a lot of the, we get a lot of the data and documentation that we need in order to submit an interconnection application. And sort of the last pain point that had to be hand calculated, the collector system equivalent impedance, is now rolled into this automated design process. So the importance of having this automated design process is that on these interconnection applications, the timelines are usually very compressed. Obviously, the developers are always need it yesterday as fast as possible. But then once you submit to the interconnection queue, you usually have to wait 3 to 6 months before the utility will even look at it and give you any feedback. And then once they give you feedback, then you have a very short window, sometimes 10 calendar days, where you have to redo the design package, answer all of the utilities questions, and resubmit an interconnection application. And sometimes that requires a significant amount of redesign. For instance, if the utility comes back and says you're going to need to upgrade this transmission line, it's going to cost a significant amount of money. But oh, by the way, if you reduce the megawatt output of the plant, then you won't have this huge cost, and that actually makes the dollars per megawatt. Even though you're reducing the megawatt, you're reducing the dollars more, and so it becomes a cost advantage to do that. But you have 10 calendar days to redesign the system, resubmit all the information, and so there's a huge need for streamlining that process, automating that documentation generation, and so that you can resubmit. If you miss the 10 days, usually you miss out on your spot in line, and so you go to the end of the line, and given these long wait times of 3 to 6 months or even more in other jurisdictions, that can be a huge penalty that the developer has to pay. And in addition, there's also monetary costs associated where you've put forward where the developer has put forward good faith deposits to the utility, and they can lose those deposits if they don't respond fast enough. So that's really sort of the landscape of where interconnection process is in the United States, and how pvDesign and rated power can help with that and automate that. In addition, MPR can also help with sort of all aspects of the interconnection process, from the very beginning of siting and sizing. Sort of, if a developer has a plot of land, how many megawatts can they get out of it? How can they design this, the PV panels or the renewable system or the battery system? Additionally, MPR helps out with the initial application, submission, and preparation. That's something that I do quite a bit. And then once we get comments back from the utility, we can do some of the refinement, iteration, and discussions with the utility to really figure out what the utility needs. Are there other options, other ways we can refine the design and continue moving forward with this interconnection? Additionally, MPR does a lot of owner's engineering services. I should mention we are not in EPC. We don't build or oversee the building and the pouring of concrete. That's not really what we do. We do owner's engineering though. And then additionally, once you've got through the interconnection application, you've built it, then commissioning, providing engineers out in the field to help commission these systems, and also troubleshoot any problems that arise either during the final interconnection or during operations. MPR would be happy to help with any of those aspects. So.
Well, thank you so much, Tom, for all this information. Actually, now I understand better why the process at least gets complicated over time. It's completely understandable. And as you said, like you've been talking a lot about the automation. You talked about pvDesign, how this process could be automated to be easy for the applicants. And from my experience, like as you already said, the timelines, about the timeline, about the time that you have, I understood that this discussion with the utilities, the back and forth process that is usually due to missing information or missing documents, is the time that actually delays this process, or partially delays this process. And it is indeed something that could be automated, and that's what pvDesign tried to do for now, to be able to automate at least the documentation, give the user the information, the documentation needed for this interconnection application. But just to understand better this time constraint of the process, I would like to ask you a couple of questions. First, I want to know if there is a certain window for this application, or if you're able to apply throughout the whole year.
I mean, it depends. As I mentioned, utilities have a lot of, it's a very diverse landscape of utilities in the United States, and restrictions. Typically, the interconnection queues are open year-round. It's just a rolling submission. There are some exceptions. For instance, PJM right now is closed. They have such a backlog. They just said, that's it. We're not accepting any more applications until we get through this backlog. But a lot of times, the timelines that are driving the developers are requests for proposals, where a utility or a municipality or another entity will say, hey, we want these many megawatts, or we need this type of power by this date. Who can provide this power? And then developers submit their proposals. A lot of times, to be even taken seriously in that proposal process, you need to have an interconnection queue number. You need to be sufficiently advanced in the queue, because the people requesting the proposals understand that there's a huge delay in this interconnection process. And so a lot of times the developers will want to get through the interconnection process as quickly as possible, so they can meet these request for proposal deadlines and show that they're a serious contender.
Got you. Very clear. And I understood that, or assume, correct me if I'm wrong, that in the queue, usually there is no standing, like some projects does not have more standing than other projects. I assume that they're dealt with in the same manner.
Mm-hmm. Yeah. All the projects are just sort of taken one after the other in the queue.
Yeah, right. So yeah, basically, since all the projects are the same, doesn't depend on the capacity or anything, and since the timeline is very short, then the need of automation is really important here. And as you already answered throughout your presentation, that pvDesign can help with this. However, as a user, I would like to know more about your experience using pvDesign, and to tell us more about a scenario or a case where pvDesign helped you in this process.
Yeah, so I kind of alluded to it in my the previous discussion, but I mean, one case that came up was it was a 80 megawatt plant. We went through the interconnection and the study process with the utility, and the utilities said it was going to be roughly 16 million to upgrade the transmission line. But if instead of 80 megawatts, you went to 40 megawatts, then you wouldn't need to upgrade the transmission line at all. And so to the developer, even though, as I mentioned, even though the megawatts went down, the cost decreased so significantly that the dollars per megawatt actually became more advantageous. So based on the rules, we were able to maintain our spot in the queue, but we had to essentially completely redesign the site and go from 80 megawatts to 40 megawatts. And so that changed all of the single line diagrams, all the collector system impedance, tie line impedance, main transformer, all the documentation that pvDesign provides. And we had to do that on a very short timeline. And so by using some of those automated features in pvDesign, we were able to rapidly turn around this pretty significant redesign of the project.
Well, glad to hear that the redesign was very helpful to you as a user, and specifically in this process. We know how complicated it is, and one of the objectives of pvDesign basically is to be the right tool for users to tackle this specific processes that could be dealt with quickly using the software. So it's one of our objectives. And just to emphasize on what Tom was explaining and how pvDesign can help you fasten this process or other processes, I would like to mention a few things that pvDesign can do in the interconnection. So basically, the software already designs automatically the PV plant, but also the interconnection part, meaning you can design the interconnection facility, either a substation or a switching breaking station, depending on your choice and also on the electrical standard of your choice. By that, I mean you can get results of the ratings and sizing of all the equipment in the substation, the short circuit calculation, the installation coordination, the clearances, the safety distances, basically all the details regarding the interconnection facility. And then what we recently launched and what Tom mentioned is the power flow model, where we have the MV collector system, which is the electrical equivalent system. It's electrical equivalent of all the systems that we have in the whole flow, from the inverter at the plant till the point of interconnection, including the power transformer of the substation, the transmission line if applicable, the battery system. So we have the equivalent system of all these systems, and of course we have all the results of all the electrical parameters, such as the reactance, resistance, or susceptance. And two of the main, or I would say main advantages of pvDesign to me are first, the iteration. Again, as Tom mentioned, it's easy to use the software and quickly iterate through the same design and make small modifications to either optimize your design or correct something based on what was requested by the utility, for example. And quickly, a few clicks, few minutes to get again all these results. And talking about the results, that's the second point, which is the documentation. pvDesign generates tons of documentation, tons of results, reports, Excel sheets, drawings. So it has full results, a lot of pages of interesting results. And that's what I would like to show you directly on pvDesign. So I can move directly to the software, show you quickly the results. Basically, give me a second. Let me move this one here. And I would like to show you mostly two of the main documents that are used for the interconnection facility, the interconnection process, which are basically the SLD of the substation or the switching breaking station, depending on the facility, and then of course the power flow model. So before I show you the examples, let me just clone this design just to show you more or less, if you've never used the software, how it looks like. So as you can see here, we have several tabs on how to design the system, how to design the PV plant, the battery system, and then you have the grid point here, where you can design the substation. You can choose the type of the arrangement of your substation, the voltages, the type of the transformer, the capacity of the transformer. You can also design your overhead line or transmission line from here, choosing the conductor, the shape of the towers, and so on. And we're giving you this flexibility so that you can customize your designs as well. And we don't want to just give you automatic, completely automatic designs. So we're giving the user some flexibility in this design. And once you generate the design, click on this button. In a few minutes, you will have the results that I was showing you just before that, which is this one. And here at the top, you have this documentation. So you have a lot of documents here. And as I mentioned, one of the most important ones for our subject are the interconnection facility SLD. So if you download it, which you can download in PDF and also in the DXF format, as you can see here, you'll find the SLD with all the equipment. For every bay, you'll find the power transformer with its rating, the XNR over our ratio, and all the other devices basically with the ratings and sizings of each device. So you find all the details. Also, as I mentioned, you can design the substation or the facility upon different electrical standards. So also the symbols of the devices or the equipment will differ depending on the standard. And the second document that I would like to show you, which is the powerful model Excel file, which would include here all the systems, as I mentioned, if all of them are applicable in the design. In this case, we have a transmission line. We have also a battery system. So here we generate automatically this diagram showing the system, the full system with the collector, the MV collector systems. And here you have the tables with all the results, starting from the generators, depends if you have the battery system or just the PV plant, the power transformers at the power station. Then you have the MV collector system with the positive sequence and zero sequence, which are once again very important in the application of the interconnection. Then you have the substation transformers details, and then the transmission lines, if applicable, as well, the positive sequence and zero sequence. So these two, we consider them again one of the most important documents in for the interconnection and for the interconnection process. And basically we try to develop even more and try to make the process smooth from our side and automate as much as we can. So for now, this is what we wanted to show you and share with you. Once again, I would like to thank Tom for joining us and sharing with us his insights. So if you don't have anything else to add, Tom, we can move to the questions if that's okay with you.
Yeah, that's fine. It looks like some people have already dropped some questions in the chat.
Great. Great. So please, if you still didn't ask your questions, feel free to drop them in the panel, in the question box. So let us check the questions that we have already.
I'll take the first one from Alex Rivera. They're asking, are there any areas Rated Power's services are most familiar with, or pretty much all ISOs and regions? And I would say it's, at least in the US, it's pretty, the interconnection process is becoming more and more standardized. Driving that trend is NERC and some of the other best practices. So Rated Power can really be used all across North America, where NERC has jurisdiction. There was another question also about how much of my talk can be applied to Europe. I'm not as familiar with European interconnection processes, but I do know that Rated Power, there's an option to use either IEEE and NEC requirements, which would be applicable in North America, or IEC standards. And Suki, I don't know if you want to show that, or you probably have more experience with the European market. So.
Yeah, exactly. And this is related to another question that we received regarding the standard, since you mentioned that, Tom. Actually, in pvDesign, we try to design with both standards, targeting the North American market and also the European using the IEC standard. So we have both standards. You can just choose it from the interface directly, and you will have your designs, your results depending on the electrical standard. And also the drawings, everything depending on that standard. We have another question, if you can take that, Tom, which is, when would you want to have the interconnection process be implemented in the utility scale solar PV systems? Should it be in the beginning part of the project being planned out, or is it generally considered when the project reaches at that stage of having interconnection to the utility grid?
So, I mean, I guess, when would I want the interconnection process? I don't have much of a say in that. NERC and the utilities really determine that. But what I will say is that, as I kind of mentioned before, the trend is certainly becoming more and more documentation upfront, right at the beginning of the interconnection process. And I mean, that trend has really taken off even in the last couple of years since I've been involved in this. And just to kind of give you a sense of scale, a couple of years ago, it was a 2-page form that needed to be filled out for the initial interconnection. Now it is about a 7-page form and requires PSSE models to be submitted for the initial application. And NERC has already stated that they want to see PSCAD models or 3-phase models submitted at the initial interconnection process. Some utilities like TVA already require that ahead of the NERC standards. So I mean, I think there's a balance to be made in terms of the interconnection documentation required upfront versus later in the process. I think there's a balance to be struck there. I think also there needs to be a lot of interconnection process reform so that developers can get information about what kind of upgrades are necessary without having to submit a complete design package, because that's very inefficient for the developers in terms of creating this design package and submitting it, and then the utilities reviewing it all, only to have 75% of their applications withdrawn. So I think there's a balance to be made in terms of when the interconnection process and documentation needs to be provided.
Thank you for answering that, Tom. We have another question from Anthony. Are you also in international like Philippines? Yes, the software could be used worldwide. So we don't have any limitation, any geographical limitation. So also talking about that, you can apply for a demonstration on our website. Feel free to do that, and so that you can use the software yourself and also have a presentation, a demonstration, and try it with your own project. Another question saying that if it's possible to design multiple interconnection facilities. Currently, it's not possible in the software. However, we are working on it right now. We're working on what we call a flexible interconnection schema, where the user is going to be able to define several interconnection facilities, in breaking stations to substations. So it's something that we're going to probably launch very soon. Then other question we have from David, maybe this one is for you, Tom. What are some of the key technical parameters to consider when connecting large-scale solar onto the grid?
I mean, I'd say sort of the first key technical parameter is the megawatts. That sort of drives a lot of how much land you're going to need, what size transformers, other aspects like that, also the cost. So I mean, that's sort of the first one that's maybe pretty obvious, but then you start getting into what power factor is required by the grid. At a lot of places in North America, it's 0.95. You have to supply that day or night is becoming the standard. So that can be a little bit tricky if it's a solar only. You got to make sure that the inverters can provide reactive power at night. And then also the power factor changes your apparent power rating for the plant. So those are some of the, I'll say, very high level design considerations or technical parameters that need to be considered. Beyond that, you just start drilling down into transformer impedances and inverter capabilities, short circuit capabilities, other aspects like that. I mean, the list just keeps going on and on and on. And so that's why it's nice to use pvDesign to really keep track of all those parameters and do a lot of that design iteration and technical design automatically.
That's correct. There's another question from Ali regarding the sizing of the components in the plant and protection and the standards used. Basically, we have several standards when designing the plant. For the interconnection part, we have the IEC and IEEE, and for the plant itself, we have the next standard, we have the IEC, we have Australian standard, the Chinese standards, we have several standards that the user can select directly from the interface. And Anthony, yes, I confirm the services are global. There's no geographical limitation to use pvDesign. And also Ahmed asked for if pvDesign specifically designed for large-scale utility solar systems, or can it be used for small scale like residential, and how is it different to other solar design and software tools? Basically, the software is used for utility scale, is true, but we have users who uses it from even less than 1 megawatt. Usually we advise our users to use it for plants from 1 megawatt up to gigawatts. However, we do have users and designs simulated under 1 megawatt, only a few kilowatts, and it's perfectly, it works perfectly. However, we do not do residential in this specific case. The software, I would say it's really different or unique. For me, I think it's because the software tackles several parts with enough details for all kind of profiles of our users, either a developer, an engineer, or an ethicist. They always can find use of the software, either in designing the plant, designing the substation, designing the transmission line, designing the battery system. We keep adding several features very rapidly. That's another important point. And also we have things like batch design, where you can do multiple designs quickly over one single parameters. For example, the DC-AC ratio, and based on certain steps, you can get several simulation. And then after that, we have a comparison tool in which you can compare. We also calculate the capex, and it's something that you can compare between the simulations. We also offer, related to another question that I saw about the sites, we also offer a site creator within the software, so you can automatically or directly within the software design or draw your site with all the elements. So we have several parts, and also another thing that I personally think is really makes a difference is the documentation that the software generates. We generate tons of pages of results, not just pages, but also accurate, and we try to give the perfect design with the most accurate results out there. So for me, that's a unique point as well. And talking about the site as well, in the other question regarding the site, we just launched, I think today, specifically for the US users, a tool where it's a parcel where you can directly from the site creator inside the software, you can just click on parcels in the USA, and you can get the information, and you can just convert them to sites directly there. So this is something new, and maybe Tom, you would like to try it as well. It's something that we just launched today.
Yeah, I'll give it a try.
Great. So I guess we don't have any other question. We hope that we answered all your questions. I hope this webinar was really interesting for all of you. Thank you again for joining us, and we hope to see you again in the next webinar. And thank you, Tom. Goodbye.
No problem. Thanks.